major support for the 10 is brought to you by Protocase, builders of electronic enclosures for scientists, engineers, and innovators, the Cape Breton Partnership, and the Cape Breton Regional Municipality, 45 Drives, experts in large storage, and Navigate Startup House. The 10 is produced by Navigate Startup House.
So Todd asked me to give a talk on deepfake technology, and I thought about how I do this without giving you 10 minutes of Nicolas Cage videos, which I'm sure some of you have seen. And I will warn you, there's a little bit of technical content here because I wanted to explain some of how this works, because it's going to change everyone's lives, even though you may not realize it. So hopefully at the end of the day, regardless of your background, you take a little bit of that away. So first, there's some legal stuff. I am currently employed by the National Research Council of Canada. Anything that I say is my own fault and does not represent the Crown or the NRCC. If you want to get the opinion of the Crown, talk to your new MP. I'm sure he'll be happy to give it to you. And this is not intended to be professional advice or commentary. So I'm going to start out with, does anyone in the room know who this woman is? Anyone? That's good, because this woman doesn't actually exist. This woman was imagined by a generative adversarial network, which is at the core of deepfake technology. This woman doesn't exist, she never will exist, but she could be in a video commercial next week. So this is another fun one. Does anyone in this room, after I've shown them that, think that either of these two people are real? Anyone? They're not. They were also imagined by a computer. Now, I'm a big cat guy, and I'm a jerk. So, does anyone think that one of these cat pictures is real? They're pretty good. I like cats. None of these cats actually exist. And none of these cats have ever existed. They were also imagined by a computer. So, I can't talk about deepfakes without Nicolas Cage. Now, my lovely wife pointed out to me, and I didn't actually know this, the reason Nicolas Cage is used in all these videos is because of a terrible movie he was in called Face Off. It was a terrible movie. Anyway, so what the computer is doing, and it's doing this in real time, is it's translating the image of Amy Adams, which is, she's acting there, and in real time replacing her face with Nicolas Cage's face. Pretty cool. But how does this all work? Now, this is another example some people might be aware of, and I don't know if there's any Star Wars fans in the room. Recently, Disney remade one of the early Star Wars in a prequel called Rogue One. I didn't know anything about Rogue One. I intentionally completely avoided it, and it wasn't until 2/3 of the way through the movie I didn't realize they were remaking the Death Star movie again, and that it was a prequel. But it was played by Peter Cushing. Does anyone know if this was before or after he died? He died in 1994. He was brought back digitally for the movie. Anyone? After? I actually don't know. But this wasn't created with deepfake technology. This was created with a huge team of people tweaking things manually. So where does all this stuff come from? How do they do it? Everyone thinks this stuff came out of ILM, Pixar, or Disney. But you'd be wrong. They actually didn't do a very convincing job. And in fact, if you saw Rogue One, you would probably understand that it was okay, but there's something not quite right. Didn't look as good as Mr. Cage there. And, as the saying goes, Hollywood has the line, you sure that's air you're breathing now? This is where it came from. You can thank people who buy video games. NVIDIA in particular is at the forefront of this technology, and a set of libraries Google produced called TensorFlow, which enable people to build artificial intelligence systems at home. And this guy in the middle, does anyone know what the guy in the middle is? It's the Reddit guy, that's right. And there was a forum on Reddit, and there was one guy, probably a guy, who realized you could use this technology to implement a paper, and you could use this technology to make fake pornography. So all of this technology traces back to a Reddit forum, which has since been banned. So this slide in particular, I want to point out because I actually made the government send me to California, and if you've ever worked for the government, getting them to send you anywhere is a really big hassle. But I wanted to be in the room when Jensen Huang, the CEO of NVIDIA, presented this slide. And a lot of people missed the significance of this slide. And the important part of this slide is right here. That's sort of where we are now. And this is not a linear scale. So between when the slide was presented in 2016, we're now coming up on 2020, and 2025, the power in those video cards is going to increase by 1,000 times. That is going to enable things that we haven't even dreamt of yet. Do you wonder why your phones can listen to you now and you can respond? This is why, video cards. So, how does it work though? And I'm sure you've all heard a little bit about neural networks, and I'm going to explain at a very high level what they are and how they're relevant to this, frankly, magical technology. I've never seen anything like that before. So the first thing is it's a really old idea. It's not a new idea. It dates back to the perceptron, a paper published in 1958 by Frank Rosenblatt. And it was modeled after the structures people observed with microscopes inside our own brains. These systems learn. So everyone thinks when you write a computer program, anybody who's seen somebody make a web page, people go and they type the code in and then it works. But that's not how these work. You design the network, and sometimes you even design it graphically, but then you feed it data and it interacts with the real world. And that's how it learns, exactly the way we do. These systems are limited because they have a linear classifier problem, and I'll talk a little bit what that means in plain English. But essentially, in 1969, Marvin Minsky, who is pejoratively called the father of AI, published a paper that said these things were basically useless. He was wrong. It turns out that sometimes old ideas are pretty good. So this is what a neural network looks like. It doesn't look like something that gets pulled out of your head. It's not gooey. There's a set of inputs, and these can be pixels or components of a computer image. They're added up into a sum, and then they're passed through an activation function, which is a yes-no gate. That's all they are. And it turns out you're made up of billions of these. The linear classifier problem is important because it stopped a lot of this because people thought it was a limitation. And what you're seeing here is, so if you had to draw a line between a domesticated animal and a not domesticated animal, and you wanted to relate it to size, okay? When you start out, you might say, well, a small cat, that's domestic, and a big emu thing, that's not domesticated, so I can draw a straight line. But as you start to add more examples, it gets harder and harder to draw a straight line through the data sets. This is a linear problem, a linear line. You can't separate the data. So what happened was this prevented their application for things like deepfake technology, although no one thought about that in 1958. The answer is a multi-layer network, and it turns out that Minsky guy knew about this. He just didn't talk about it. And it solves the dimensionality problem. It lets me draw circles in that graph. That's all that means, is so that if I want to say that's a domesticated animal and that's not, my computer can draw a circle around it. That's all it means. Most of the early detractors ceased to be relevant, and what this means is they died. So the other important thing is it turns out these architectures are easily implemented on those video cards that everyone bought video games and people made faster and faster and faster. So modern computers are unbelievably fast. I'm fortunate enough to be of an age where I saw the very start of this. It was some of the earliest computers, and I grew up and saw it emerge and develop. Now you can buy a video card that has 4,300 processors for about $1,500 bucks. This allows experimentation. Everyone thinks there's science behind this. No, this is the early days. What that enabled was that the computers got fast enough as you could train them on these huge volumes of data and video and then realize it didn't work and go back and change it. And then you could run it again. And it didn't take months. You could do it in days or hours or even minutes. So once these systems are trained, and remember, they're not programmed. You show them all the information in the world, they learn from it, and then they can do cool stuff. Once they're trained, they run in real time. So that Nicolas Cage video I showed you, that wasn't running for months and months and months. It only took a few seconds. It ran as you watched it. The actual driver for this is autonomous cars. And no, really, it was autonomous cars. That's what revitalized all the interest in this. See, Minsky thought that we could do artificial intelligence by directly understanding the brain and then translating the rules with our brains. And they tried to do that to make cars drive. And if you saw some of the early DARPA challenge cars, these things didn't even get out of the starting gate. They just drove right into concrete walls. The first car that used this technology completed the course. And that opened a lot of eyes. This is all a multi-layer neural network is. So instead of that one thing I showed you early on, there's an input layer, there's this magic hidden layer, and there's an output layer. And what passes through there is essentially values that could correspond to the pixels in a video image. So deepfake software, fundamentally enabled by this technology. I can't talk about how deepfakes work until you sort of have an idea of that. I hope you all do now. There's 3 key components that are used. One of them is called an autoencoder. The other is called a convolutional neural network. And this is the real magic one, the generative adversarial network. That's going to change the world going forward. This stuff's all community-driven, open source. See, the magic stuff with this, too, is that the valuable part isn't the network. You can actually go download online Tesla's self-drive algorithm. They publish it because they want people to make it better. I've actually implemented it as an exercise. But what I don't have is I don't have access to Tesla's data. They've got petabytes of data of people driving cars. And that's what you need to make the networks work. So if you're curious about this stuff and want to actually download the software, you can go to GitHub, Face Swap, Deepfake Lab. They're the most popular ones. They were used to produce the examples that I made. It's all free, really. Like, this stuff's all free. The valuable stuff's the data. And warning, so this is where I'm going to explain a little bit about how these things work. So if you're bored, thispersondoesnotexist.com. Fire it up. That's what the QR code is. And you can go look at an endless stream of faces imagined by a neural network of people who don't actually exist. This person does not, and if you're curious, the other images came from this cat does not exist. It's actually So, an autoencoder. An autoencoder copies the inputs to the outputs through a magic hidden layer. The inner layer represents a code that translates the inputs to new outputs. So it learns to encode information, and this is the key, in an unsupervised manner. So I don't tell it how to relate the two. Its structure tells it how to do that. So it simultaneously learns how to reconstruct the input. So if I give it an input, it'll recreate the output. So what you do is you say, I want to tie 2 faces together. So I'm going to use somebody's face as an input and somebody's face as an output. And the autoencoder will learn how to connect those 2 things if you show them enough examples of faces. So the inner layer learns the layer between the 2 automatically. And an eye for an eye. So one of the early tells in these, if you looked at a lot of them, was the eyes weren't quite right. And if you look at some of the examples I'm going to show you later of cats, you can see it pretty clearly. They fixed that. And they fixed it with the GAN, the generative adversarial network. So that's an autoencoder. You've got inputs. The magic happens in the middle. It relates the inputs to the outputs, and it feeds back on itself. A convolutional neural network. This is one of the other key components, and this is the relevant one for self-driving cars, and it's also how your eyes process me and everything else around you. So it's a multilayer neural network that's specialized for feature extraction in images and other data. It's inspired by what's in your visual cortex. That's how your brain works. And it uses convolution instead of matrix operations to transform data. So what that actually means in English is instead of it multiplying or adding data together, it takes a picture of a function and applies the function to the data. So a little square or a squiggle. And it's used to identify features like edges. And then your brain reconstructs these all into more complex pictures. And it's fundamental to most advances that we've seen in this space, including self-driving cars. And the big one, 2004, Young showed that they could be accelerated on a video card. And that was the first big breakthrough in all this. And that's what they look like. Don't worry, I'm not going to go through this. The important thing to take away is that it moves from something that looks like a squiggle. And there's a series of layers that extrapolate features out. And the output at the end could be the computer saying, hey, they're trying to draw an S. And I know that's an S now. So a generative adversarial network. That's how deepfake stuff works, and it combines all of this together. They were invented by Ian Goodfellow in around 2014, and they basically make these networks fight to compete using game theory. So they make them play their own video game. One network tries to generate new data from a training set of real-world images, or whoever you're trying to fake. The other network tries to evaluate and figure out, is that network telling me the truth or not? So the two networks compete with each other. So the generator deconvolves, or basically deconstructs the image, the other one reconstructs it, or imagines it. So that beautiful face I showed you at the start of this was imagined by one of these networks that had been trained. The other interesting thing, and this is like state-of-the-art stuff going on right now. May 2019, so this spring, Samsung demonstrated that they could do those type of videos with one photo of a person, get that quality. And that's what GAN looks like. There's a generator which produces fake data. There's real images. There's something called a discriminator, which tries to figure out, is this thing telling me the truth or is it lying? And then it calculates the difference, or the generator and discriminator loss. That loss is used or fed back to the start of this to correct the input and make it better and better and better and better. The examples I showed you would have been run somewhere between 100 and 200,000 times to train them. But once they're trained, you get those phenomenal results. So no technical talk is complete without an xkcd graph. And this is a good one, our comic. So what if the answers are wrong? Well, just stir the pile of information until it starts looking right. And that's actually not incorrect. And when you build these systems, sometimes if you just shuffle the input data around, you get a better result. They're too complicated to fully understand and analyze, so people need to learn, or the systems need to learn. And the faster we can do that, the better they get. So what can go wrong with all this stuff? It's more fun to talk about the wrong. So this is one big concern, and everyone knows who the guy on the right is. Nancy Pelosi, the Speaker of the House in the States, she actually was attacked using a video technique where they slowed down her image and made her look like she was incompetent, or perceived to be incompetent. And it's one of the first uses of video in that manner, probably done by the wonderful gentleman on the right. But this is just the beginning stuff, because now you can't trust video. Like that's a reality. That's not science fiction. That's right now I can make you a video and you can't tell me if it's real or fake. Oh yeah, it all works on audio too, not just images. So if you have audio recordings of people, you can model the audio completely. You can speak in your normal voice, the computer will turn it into their voice, and you can't tell the difference. Which leads us to this wonderful thing. Now look at the date, September 3rd, 2019. New stuff. Deepfake was used to scam a CEO of $243,000. What they did was they impersonated the voice of the chief financial officer of this corporation and instructed the CEO to release funds to an account, which he did because it was his buddy. He could tell because it sounded the same. This actually has led to changes in a lot of corporate policies now. It's a real problem, so you can't trust a voice on the phone anymore. So great stuff. A new technology comes out, and what does the internet do? We use it for pornography, we use it for fraud, and cat pictures. But, like all great technologies, it's where it starts. But that's not necessarily where it ends up. So first off, California just passed in October, I guess 2 weeks ago, AB 602 and AB 730, which specifically addresses the use of this technology to produce unauthorized pornography and, more importantly and interestingly, political interference, and that comes into effect in 2020. DARPA launched a project to actually build a neural network that can detect this stuff to see if it's fake, but there's a problem with that. Remember how that discriminator worked? Turns out if you build a better system to detect the fakes, you can use the same technology with that GAN technique to make even better fakes. And there's a lot of discussion that it may actually be impossible to detect these going forward. Speech-to-face. This is a really cool one. Again, all open source. It turns out if you let the computer listen and train on your voice long enough, it can build a model of what you look like. Because it turns out the shape of your skull impacts how you sound. And they've actually been able to reconstruct pretty good examples of what people look like from just their voices. Cancer research. It turns out you can use GANs to compete and fight to produce the best protein molecules and receptors to block various pathways that are important for cancer treatments. Telepresence. This is an interesting one. So another way to think about a GAN is it completely models what you look like as a human being. Well, if you send that in advance someplace, you only have to send the little tiny changes. So you can build incredibly photorealistic telepresence technology over very low bandwidth links. Music and text generation. So the relevance to our previous speaker. You can use this stuff to make music, and a lot of people kind of get that. But what's really interesting is you can use it to make books. People have published some stuff that has been produced by GANs from studying authors, and they've actually come up with some pretty interesting stories with plots and everything, but they were imagined by a computer. And one of the, Marcel Lecan, one of the founders of all this, basically said this stuff is unbelievable, and GANs are the most powerful machine learning and artificial intelligence tool we have right now, in my opinion. So, with that, I will leave you with a bunch of stuff now that the cat is out of the bag. None of these kitties actually exist, but I use these as an example because unlike the face generator, which actually got too good, a couple of these are screwed up, and they're screwed up in horrific ways. That kitty doesn't look quite right. This kitty doesn't look right. This kitty looks pretty good, though. This kitty is basically, I couldn't tell you that wasn't a real kitty. And I look at the eyes, because our brains are especially attuned to emotion and facial expression, and eyes are really hard to fake. But none of these kitties actually exist. So with that, I'll wrap it up.
The 10 is produced by Navigate Startup House.